Hello everyone, I am Amruthavarshini Gopal and today I will be explaining my experiment titled Implementation of a Multi-Layer Perceptron for a Non-Linearly Separable Data, the XOR problem. In this presentation, I will walk you through the aim, theory, procedure and I will also explain the code in a simple line-by-line manner. So, the aim of this experiment is to implement a multi-layer perceptron or MLP to correctly classify the XOR data. XOR is a very famous example of a non-linearly separable problem, meaning a single straight line cannot separate its output. So, this experiment helps us understand how neural networks learn patterns that are not possible with simple perceptron. To understand why we need an MLP, let's quickly recall how XOR works. In XOR, the output is 1 only when the two inputs are different, like 0 and 1 or 1 and 0. If you plot these points on a graph, you will notice there is no single straight line that can divide the zeros and ones. This means a single layer perceptron fails because it can only learn linear boundaries. To solve this, we introduce a hidden layer, and this architecture is called a multi-layer perceptron or MLP. The hidden layer transforms the input into another space where the XOR data becomes separable. The MLP uses the sigmoid activation function. It learns through forward propagation and it updates its weight using backward propagation, which reduces the error over time. So, overall, the MLP can learn XOR because it can model non-linear relationship using hidden neurons. So the procedure of the experiment is very simple. First, we set up the XOR input values and their corresponding outputs. Next, we design a neural network with two input neurons, two hidden neurons, and one output neuron. We initialize all the weights randomly, then we repeatedly perform forward propagation to compute the output and backward propagation to compute the error and update the weights. So now let me explain the code in an easy way. We start by importing NumPy for calculations and matplotlib to plot the loss. Then we define the XOR inputs. For example, 00, 01, 10, and 11. Along with the expected outputs 0, 1, 1, and 0. After that, we set the number of neurons in each layer and choose a learning rate of zero point 0.1. We randomly initialize two sets of weights, one connecting the input layer to the hidden layer and another connecting the hidden layer to the output layer. Next, we define the sigmoid activation function. Then we write the forward propagation function which calculates the hidden layer output and then the final output of the network. After that, we define the back propagation function which computes how much error the network has made and how the weight should be updated to reduce the error. So the training loop runs for 10,000 iterations. In each iteration, we perform forward propagation, calculate the loss, back propagate the error, and update the weights. We also store the loss so that we can plot it later and see how the network learns. Finally, we use the predict function to test the trained model with inputs like 1, 0, 1, 1, 0, 1, and 0, 0. The network correctly predicts the XOR outputs after learning. So, to conclude, this experiment proves that a simple perceptron cannot solve the XOR problem, but a multi-layer perceptron with a hidden layer can easily learn it. The MLP effectively reduces error using back propagation and successfully classifies the XOR data. Thank you.